Hi, today I'm going to demonstrate how to use some simple electronic parts to create an electrochemical cell that will split water molecules into hydrogen and oxygen atoms. To begin, we're going to create a galvanostat, which is a device that will hold the current constant in our circuit. To build the galvanostat, we are going to use 4 batteries, a solderless breadboard, a voltmeter, one 10-ohm resistor, and some wires and alligator clips. Now we are going to connect the four batteries in a positive lead to negative lead, positive lead to negative lead. This will allow the voltage to add up and complete our circuit. It is important to make sure that none of the leads touch because this will cause our circuit to short. Now, we are going to connect our circuit to the solderless breadboard. Next, we are going to connect our 10-ohm resistor into the circuit. One end of the resistor must be connected to the positive end of the circuit, and it is not critical where the other end is connected. Now we are going to connect our circuit to the voltmeter. It is important that you connect the black end of the voltmeter to the negative side of the circuit and red to positive. Now I'm going to turn on my voltmeter. If the circuit was assembled correctly, then the 4 9-volt batteries, when added up, should measure approximately 36 volts on the voltmeter. Now we are going to connect our galvanostat to the electrochemical cell, which will draw power and use that power to split water into hydrogen and oxygen molecules. But first, we need to clean the nickel electrodes. The way we're going to do this is to simply soak them in some cola beverage for about 5 minutes. Now that 5 minutes has passed, our nickel electrodes are prepared. We are going to rinse them in water and connect them to our circuit. To hold the electrodes in place, we're going to use a piece of styrofoam. Otherwise, the current will not transfer evenly. Before we proceed, one important thing to note. The electrodes are made of nickel and are poor catalysts. Therefore, we are going to grow a catalyst on the electrodes so that we can improve the efficiency of our electrochemical cell. Now we are going to connect our electrodes to the galvanostat. Please note that I have taken great caution to make sure that none of the open wires touch, as this will cause the batteries to heat up and present a safety hazard to the experiment. Now that we have connected our electrodes to the galvanostat, we should notice that the voltmeter is still reading the same amount of voltage. This is because it is an open circuit and there is no solution drawing power from it. Now we are going to add a conductive solution to our electrochemical cell. It has to be conductive in order to be able to pass charge and draw power from our circuit. The conductive solution I will be using is phosphate buffer. Once we put the electrochemical cell back in, we will notice that the voltage should start to drop. We should make sure that the electrodes are in the solution. Now we should notice that the voltage reading should start to drop. This is because the conductive solution is drawing power from our circuit. Now I'm going to turn on stirring from the magnetic stir plate. You'll notice that on the voltmeter, the reading is no longer the sum of the 4 batteries, but rather the current running across our electrochemical cell. Note that the voltage right now reads about 1.96 volts. Now we're going to see how the voltage changes with the addition of the cobalt nitrate catalyst. Once we add this catalyst to the phosphate buffer solution, we will be able to see that the catalyst sheath has formed on the anode of the circuit. The crystals will dissolve fairly quickly. Now the voltage is at about 1.87 volts. Now we will add a bit more cobalt nitrate. Again, the crystals will dissolve fairly quickly in the solution. Now the voltage is at 1.81 volts. We will keep adding this cobalt nitrate grain by grain until the addition of the catalyst does not change the voltage. Now the voltage reading is at 1.8 volts. Now the voltage is at 1.78 volts. Now the voltage has hardly changed with the addition of the catalyst. Now we know that the catalyst sheath has fully formed on the anode of the circuit. I'm going to add a little more cobalt nitrate to make sure that the catalyst is fully formed on my electrode. The reason we are trying to make the voltage drop is to increase the efficiency of our conductive solution. The less energy that it uses to split the water molecules, the better. Before I stop the stirring, I'm going to look at the measured reading on my voltmeter one last time. It reads 1.68 volts. Now I'm going to stop the stirring, and you'll notice that there is a brownish black film on the anode of the circuit. This is an oxidizing sheath that will help draw oxygen to this part of the circuit with a new phosphate buffer solution. Now we're going to switch this phosphate buffer solution with the catalyst in it for a fresh dose of phosphate buffer solution without any catalyst. Now we're going to put in the electrodes and turn on the stirring again. Now we're going to observe the catalytic sheath's work on splitting the water molecules. It will take a few minutes to happen. Now that the electrodes are in a clean phosphate buffer solution, we can look at the voltmeter and observe that it now reads 1.59 volts, which is the authentic voltage needed to split water molecules. We started at 1.97 volts, showing a difference of about 400 millivolts. That shows the voltage savings that we are getting by forming a catalyst on the nickel electrodes. Now you will be able to observe that the water is splitting into hydrogen and oxygen gases, oxygen being drawn to the anode and hydrogen being drawn to the cathode. What I've shown you today is how to use some simple household items to create a galvanostat. This galvanostat can power an electrochemical cell with phosphate buffer solution. Then, you can use cobalt nitrate and the phosphate buffer solution to create a catalyst on the anode of the circuit. This catalyst increases the efficiency of the electrochemical cell. This efficient cell can be used to power ordinary household items, such as weed whackers, lawnmowers, and even automobiles. This electrochemical cell can also be used as an alternative to fossil fuels in the future. Thank you.